Welcome back, all you cats and kittens. Alright, so what we're going to do today is almost done with the book. Volume of Pyramids and Cones. So today, obviously, by the end of today, you'll be able to find the volume of a pyramid and find the volume of a cone. And some irregular solids that involve those figures as well, some composite solids. Let's get right into it. Volume of pyramid. Volume V of a pyramid is... Any ideas? Take a guess. If you said 1/3, that's a tricky one to get, of base times height, you were correct. So the base is the area of the base. The base is the side that's opposite of the apex. As we said before, the height makes a 90-degree angle with the base and goes to the apex. Okay, all the other sides are triangles. Those only are needed if we're dealing with surface area, where you would need slant lengths and stuff like that, but we're not doing surface area at this time. So B is the, as I said, the area of the base. Now, depending on what type of figure it is, your area is different. And H is the height. Now, depending on what area your base is, your height is always the same. So, in this case, what do we got here? That looks like a, what do you think? Rectangle, length times width. So, 5 times 8, 5 times 8. All right. So, the base of problem number 1 is 40. The area of this is 40. So, what's the height? Right angle, dashed line, middle, height is 14. Find the volume. 1/3 of base, which is 40, times height, which is 14. 1/3, so 40 times 14 divided by 3, or 1 divided by 3 times 40 times 14, is 187 cubic units. All right? Didn't put a unit here because there is none given in this problem. Ready to do some more problems? Hopefully. Now you're going to do this one. Now, just so you know, the pyramid, the apex of the pyramid does not have to be over the dead center. You can take this thing, and as we did before, you can put this wherever you want. It doesn't matter. Okay? So, let's give you some hints right here. This is the base blown up. I didn't want to put it in here because it got a little confusing, so I put the base out here. So, the area of the base used in the formula for the area of a regular polygon. Do you guys remember what the polygon is? The area is 1/2 the apothem times the perimeter. So what is the apothem of this base? 3.5. I didn't even give you a trick. I should have given you the radius. Still made it a little tricky. All right. The perimeter is 1, 2, 3, 4, 5, 6 sides, and each side is 4. So it's 6 times 4, which is 24. So the base is 1/2 of 3.5 times 24, which gives you an answer of 42. So the area of this base right here, which is this base, is 42. Now, what is the height of this pyramid? Well, the height goes from the base to the apex, so the height is 10. So 42 times 10 times 1/3 gives you a volume of 140 cubic inches. Bam! And that's the answer. Any questions with example number 2? No? All right. Problem 3, 4, and 5. Go. All right, you should be done. Problem 3, the volume is 1/3 the area of the base times the height. A square base, or rectangular, 11 times 11 is 121. So the area of this is 121. The height is 12. So it's 1/3 of 121 times 12, 484. Pretty easy. Rectangular base. So, you know the volume of a pyramid is 1/3 base times height. So the base is length times width, once again, which is 8 times 9, which is 72. 1/3 is 72 times your height, which is 13. Answer is 312 cubic units. All right, this one's a little tricky. You got 8, 8, and 13. Now, this is a triangular base, obviously, right? So, what is our 1/2 base times height, right? What's our base and our height here? Well, it's 8 and 8. The base and the height of a triangle are always the ones that are adjacent to the right angle. 11.3 here is the hypotenuse, so we use 1/2 8 times 8. We don't even care about the 11.3. You get 32. The height from the base to the apex is 14. 1/3 of 32 times 14, 149.3 cubic units. All right. 6, 7, and 8. Go, go, and go. There's your volumes. First one, we have a trapezoidal pyramid. 1/2 height of the trapezoid is 6. The two bases are 9 and 17. Half of 6 times 26, 3 times 26 is 78. So that's your base. Your height is the distance from the trapezoid to the apex, which is 10. So 1/3 of 78 times 10 is 260 cubic units. Right here. Looks a little tricky, but this guy right here is a square. Look at opposite angles are both 90. These are both 90 as well. It's just slanted over a little bit. So the base is length times width, or 20 times 20, or 20 squared, which is 400. The height here is not 18. 18 is the slant length. We want the one that makes a 90-degree angle with the base, which is 16. 1/3 of 400 times 16. And as a final answer, you get 2,133. All right. This one, as weird as it looks, it's just the way the shape is drawn. The base right there is length times width because it's a rectangle, 12 times 26, which is 312 units. Got it? 1/3 base, which is 312, times height, which is 30, gives you 10 times 312, 3,120 cubic units. All right? That, my friends and my students, is the volume of a pyramid. Now, a type of pyramid with a circular base is a cone. So a cone is pretty much a pyramid with a circular base. Now, because the base is circular, it doesn't have triangles leading to the apex. It just has one cone leading to the apex, like one giant triangle if you were to unfold it. Volume of a cone is 1/3 base times height. 1/3 the area of the base times height. The same exact formula as a pyramid. However, a cone always has the same base. The base of a cone is always a circle, and the area of a circle is what? B is the area of the base, H is the height. What's your base equal? As we did with the cylinder, the base is pi r squared. So the volume of this is radius, height, pi 1/3 pi r squared, which is the area of your base, height. One straight formula, 1/3 pi r squared h. Got it? Area of a cylinder, pi r squared h. So it's just a 1/3 difference. Right cone. So volume equals 1/3 pi r squared h. 1/3 pi, radius is 9.5. Height is 16.8. 1 divided by 3 times pi times 9.5 squared times 16.8. 1,587.8, which is the number of cubic units. So it's about 1,588. Right. I think that's pretty easy. Ready to do some more problems? Try problem B and C. Now, problem B, I'm just going to give you a bunch of different things to do, and then let you guys go off on your own and do a bunch of examples. So, set B. You have an oblique cone here, all right? Now, this oblique cone, the same concept as an oblique cylinder, okay? When you pop it over, it still has the same volume as a cone. Volume of a cone, volume 1/3 pi r squared h. It doesn't matter because as before, remember I told you to take all the cross sections, all you're doing is tilting the cross sections over instead of going straight up. So 1/3 pi, radius is 4.5 squared, and your height is 12. 1/3 times 4.5 squared is, times 12 is 254.47, or about 254 cubic inches. Remember, lower than 5, round down, 5 and above, round up. And it doesn't matter where this point is. This point could be all the way over here. It could be all the way over there. It could be in the middle. As long as it's at 12 inches high, that's the bottom. Now, say you're not given the height. Say you're going to say, let's see, find the radius. So you have the radius and you have the slant length, but you need the height. What can we use to find the height? Yes, you can use the Pythagorean Theorem. C squared equals A squared plus B squared. 10 squared, the radius here is 6. Sorry, start first. Get a little excited. Math excites a lot of people. So 10 squared, okay, so you got the volume equals 1/3 pi r squared. Volume equals 1/3 pi 6 squared times the height. But we don't know what the height is. It is not 10. It's the piece that is the right angle to the base. So we know that 10 squared plus height squared equals 6 squared, right? 100 plus h squared is 36. 64 is h squared. H equals 8. Pop your 8 in that answer. 1/3 pi, 6 squared times 8, 301.6, or about 302 cubic feet. All right? Take your time. Got it? 3 problems. Go. Use your formulas in case you need them. Radius, height. 1/3 pi, 5 squared 13, 340.3. It's like a plug and play, as they say. Oh, 22 is not your radius. 22 is your diameter. So as with cylinders, you have to make sure your answer always has the radius given to you and do not plug in the diameter. So radius is half of 22, which is 11. 1/3 pi, 11 squared times the height, which is 26, 3,294.5. All right. Not given the height, we're given these two. So you have to use the Pythagorean Theorem. C squared equals a squared plus b squared. 45 squared equals h squared plus 11 squared. 2,025 equals h squared plus 121. Subtract 121 and take the square root of 1905. And you get height is 43.6. So this distance is 43.6. Good, because it's less than 45, which is your hypotenuse. 1/3 pi, 11 squared times 43.6. Give me an answer, 5,525. Got it? Good. 3 more. 2 problems, 13 to 14. And 15. 13 to 15, we should probably say. That probably sounds a little better. All right, once again, oblique, that's all right. Right there, we have the diameter, we need the radius, so half of 15 is 7.5. 1/3 pi times 7.5 squared times 26. 1,531.5. Not given the height here, so we have to find the height. Way to find the height is 13 squared equals h squared plus 7 squared. 169, subtract 49 from, you get 120. So it's about 11. The height is 11.0. It's like 11.04, but we'll just say 11.0. 1/3 times 7, which is your radius squared, times 11 is 564.4 cubic units. And problem 15, what do you notice? I don't see 1 cone, I see 2. So you have to find the volume of the cone on top, volume of the cone on bottom. Height is 8, height is 9. So we've got the same thing here in both cases. The only thing that's going to change is our 2 heights. So 1/3 pi, 6 squared times 8 gives you 301.6. 1/3 pi, 6 squared times 9 gives you 339. All right. Where we do the 2 numbers, add them together. The total volume is the volume of the top plus the volume of the bottom. 301.6 plus 339, and it gives you 640.9. Good? Any questions? Awesome. So, do these quick problems quick. This was your homework. So, find the volume of a pyramid. 1/3 pi. Wait, that's not right. Let's just say 1/3 BH. No pi there. Oh man. I'll erase that. So it's 1/3 BH is your volume of this. Your base is a square. 5 squared is 25, right? So 1/3, 25 times the height here, which is 6, is 50. Volume of a cylinder. There it is. 1/3 pi r squared h. 1/3 pi 10 squared. Height is 13. 1,361. Problem number 3. 2 times 5 is 10. That's your base. Height is 4. 1/3 of 10 times 4 is 13.3. Okay? Pi, 1 squared times 1/3 times 2. 2.1. Triangle, 1/2, 3 times 4 is 6. 6 times 3 is 6. You can either use this as your base or this is your base. Oh, sorry. The bottom is your base or the right-hand side is your base. Either one will give you the answer. And this is cubic inches, cubic meters, cubic centimeters, cubic millimeters, cubic inches. I messed up. I should have put the units. Oops. All right. I'll fix that on the other sheet. Now, problem number 6. The problem's 8. You have a 6-sided, hexagon. So the base area is 1/2 apothem, which is 8 times the perimeter of this. 12 times 6 is 72. is 288. Volume is 1/3 times 288 times 17 is 13.3. Right? That's that. Alright, next one. Example 18. Find the volume of the composite solid. So now what we're going to do is we're going to find the volume of solids on top of solids. So because these two solids right here, what do you have to do with them? You have to add them because they're one on top of the other. You have a cone on top of a cylinder. So the volume of the solid equals the volume of the cylinder, volume of the cone. As I said before, you're going to add the two together. So the volume equals the volume of the cylinder plus the volume of a cone. What is the volume of a cylinder? Pi r squared h. Volume of a cone? 1/3 pi r squared h. So pretty much the same exact thing here. The only difference is one is a pi, one is a 1/3. Now, radius is going to be the same for both of these. The radius here is 3. So it's pi 3 squared times the height of the cylinder is 7. 1/3 pi, same 3 right here. 3 squared, the height of the cone is 4. Type this into an equation, you get 63 pi. Type this, 1/3 of 9 is 3 times 4 is 12 pi. You add them together, you get 75 pi. 75 times your pi button is 235.6 cubic centimeters, which is about 236 cubic centimeters. All right, what you guys try? 18 and 19, go. Well, what you should see there is, you should see a hole in that picture. There is a cube, and that cube has a cone cut out of it. So the volume of a cube is s cubed. 5.1 cubed is 132.7. Volume of this cone is 1/3 pi r squared h. The radius here is not 5.1, it's half of 5.1, which is 2.55. So 1/3 pi, 2.55 times the height, which is still 5.1. 34.7. Subtract the two. 98 cubic meters. Easy as pie. Problem 19. Adding. You have a pyramid on top of a pyramid, and both pyramids happen to be the same. Volume of the first pyramid, 1/3 base times height. The base here is 3.3 times 3.3, because it's a square. The congruent marks. The base is 10.9. So 1/3 of 10.9 times the height, which is 2.3, which is 8.4. Now the other pyramid happens to be the same exact thing, so you do the same exact stuff. 10.9 base, multiply it in, you get 8.4. You could have just multiplied that number by 2 if you'd like. That's what I would have done. Add the two together, and you get 16.8 cubic centimeters. Right? Boom, another 2. What do you see? I see 2 pyramids again. 2 pyramids with a square base. So the volume of the blue pyramid, 1/3 BH. The base is 10 times 10, which is 100. The height is 11. 1/3 of 100 times 11 is 433.3. The red cylinder, the red pyramid, still has a base, 10 times 10, which is 100. 1/3, 100 times, the height here is 1/3, or 13. So that's 366.7. All right. What do you do with the two numbers? You add them together, all right? Boom, 800. You like that? Boom. All right, problem 21. You have 2 pieces. Pyramid on top, 5 times 6 is your base, 15, which is 90. The height is 7. 1/3 of 90 times 7 is 270. This right here is a rectangular prism. Length times width times height. 15 times 6 times 8 is 720. One's on top of the other. Add them together. So when you add them together, 210 plus 720 does equal 930. All right? Let me slide back here a little bit. I'm looking too big on the screen. All right, 22, 23. We got 4 more problems. So, what do you see there? I see a cone on top of a cylinder. So, the volume of the cone is 1/3 pi r squared h. Radius is half of 14, which is 7. So, the height here, since the whole thing is 56 and this is 28, 56 minus 28 equals 28 as well. So, the height of this cone is 28. So 1/3 7 squared times 28 equals 1437. Pi r squared h right here. Same radius, which is 7. Pi times 7 squared times 28, because the 28 is the height. 4,310. Add the two together, because one's on top of the other. 1437 plus 4,310. And it gives you 5,747 as an answer. Right? Guess what? Problem number 3 is almost identical. It's just slipped down, and you have an oblique cone instead of a regular cone. So, volume of the cone again. Well, if this is 82, this is 48. 82 minus 48. Oh, sorry, radius first. 30 divided by 2 is 15. 82 minus 48 gives you the height of your cone, which is 34. 1/3 pi. 15 squared, radius squared, times the height, which is 34, gives you 8,011. Radius is still 15. Pi times 15 squared times the height, which is 48, gives you 33,929. Add the two together, you get 41,940. All right, next one. All right, this is going to be homework. You have a pyramid inside a cube. So, volume of the pyramid, s cubed, 10 times 10 times 10 is 1,000. This pyramid right here, 1/3 BH. Now, this is a tricky one. All these sides right here are all the same, right? But what do they equal? Now, the way to find them is, you have a right triangle here. All right? Now, with this right triangle, this is 5, this is 5, this is 5, 5, 5, 5, 5, 5. So you have 5, 5, a right triangle. 5 squared plus 5 squared equals c squared. 50 equals c squared, and that's 7.07. So this c is 7.07, 7.07, 7.07, 7.07. So the area, the base here is 7.07 squared, because it is a square. So it's about 50. Actually, it is 50. 1/3, 50 times the height is 10. 166.7. Subtract the two, because you're taking the pyramid out, and you get 1,000 minus 166.7, 833.3. If you want to repeat it a bunch of times, you can. Cubic inches. All right. Number 2, cone. 1/3 pi r squared. H. So pi r squared times 2 is 2.09. Pi r squared. 1/3 pi. 1/2 now squared. Height is 1. 1/4 times that is 1/12 times pi is 0.26. Add the two together, and you get a 2.35 cubic feet. All right? And that completes the volumes of, what do we do? Cones and pyramids. And then the composite solids that are involved with it. So, one more thing left, and then we're done. So, we know volumes pretty much of almost all 3D figures. You know how to find those things. You know how to find the composites with it, which is excellent. So, until the next lesson, have a good day.